Hi everyone, thanks for joining us here today at .NET Conf. I've heard you've listened to a lot of great things throughout the day. We're happy to be here today showing you some debugger tips and tricks for Visual Studio. And my name's Casey Anderson, and this is my buddy.
Hi, I'm Casey's buddy. My name is Nikhil.
We both work on the Visual Studio Diagnostics team. I specialize or work mostly primarily on debugging experiences, and Nikhil does.
Yeah, I work primarily on profiling and performance tooling experiences.
Yeah, and so our Twitter handles are up here if you want to follow us on Twitter. I threw up some quotes here for you to look at. Essentially, one of the reasons we want to talk to you about debugging today is because oftentimes we're taught how to code, but we're not taught how to find and fix those issues quickly. I know when I was in school, I don't know about you, Nikhil, but it was mostly printf or console.writeline, and that's how I did a lot of my debugging. Exactly. So in Visual Studio, we work on these developer tools to help you find and fix your issues faster. And so today, we're going to try to go through several tips and tricks, some debugging, some profiling, to make you more productive. And then if we get time at the end, we'll show you two new things that are coming in Visual Studio 15 preview. And our demo today is going to be mostly done in Visual Studio 2015. And I heard Update 3 RC was released today, so go download that. With that, I'm just going to jump into Visual Studio here and start a demo. So Nikhil and I are working on this web application, and what this application does is, we're going to try to compete with Uber. Just kidding. But it's essentially a shuttle service where you'll get a list of cars and then a driver associated with that car. So before I hit F5 to start debugging, I just want to point out here that you could click on this to start debugging, or you can click on the drop-down. And what appears here is different debug targets. So for example, if you wanted to test out our client app in Google Chrome, you could select that, or Firefox, or Microsoft Edge, but I'll go ahead and stick with Internet Explorer today. And so when I push that button to start debugging, my client application is going to spit up. It's going to start talking to this web service we have in the background that's going to provide the driver details to us. Oh wait, I got an exception.
Casey, did you remember to start the service?
No. Thanks for reminding me, Nikhil. So I got this exception because I hadn't started the web service yet. And we just use that web service to talk to our backend to get our driver information. I could right-click on the service itself and start that up individually, but I don't want to have to do that every time. So instead, I'm going to go right-click on my solution in my Solution Explorer, go down here and click Properties. And this pulls up the Solution Properties page. You can see that it's set to a single startup project right now. But I want to change this to multiple startup projects. So I want to debug our client application, but I want to run the service, and I don't necessarily need to debug it today. So now that I have my multiple startup projects, when I hit F5 and start again, I'm hoping my service starts, my vehicles will display, and my driver details will come up from the back end. Unfortunately, it looks like my driver is unknown with this dummy picture here. I'm expecting pictures of our actual drivers from the Diagnostics PM team and with their name associated. So let me see if it's just a one-off or if it occurs for everything. And it seems like it is. So if I'm not quite sure what to investigate first here. I know that when this dummy picture appears, it's often what's happening is I'm unable to retrieve the driver from the back end, and so we fill in this dummy data. Well, because I'm running Visual Studio 2015 Enterprise, I have IntelliTrace available to me. And IntelliTrace is found inside the Diagnostic Tools window. So I'm going to go ahead and zoom out here and show you this timeline view of the diagnostic tools. So pay particular attention to this events track here. And on the events track, we have these little diamonds that appear that show up as our events. So when I select them, in my events tab, you can see the events appear there. And let me zoom in, not zoom out here. And as I zoom in, I can select different events. So my events list and this timeline correlate. When I click on this gray diamond, it shows me that I've got an ASP.NET event happening. The next one is a program output event. Then the next one is an exception event. So IntelliTrace has clued me in that an exception is being thrown in my code right after I make a request. So something's happening there. In this events list, like I said, we've got ASP.NET events show up here, program output, including output from things like debug.writeLine. So we have this is just a web application, so we don't really have a console we're working with. So we can use the debug.writeLine to print output to the IntelliTrace events here. Okay, so the exception is what I'm mostly concerned about right now. Got to go fix what's happening. When I click on this exception, I can double click on it, or I can click Activate Historical Debugging. And what that's going to do is that's going to take me back in time in my application to the point in code that this exception occurred and the time at which it occurred. So if you see the call stack here, you can see this label Historical Debugging with the call stack. So this is the call stack at the time of the exception. We also have some variable windows that participate in this historical debugging mode. And you can see the exception. It's just a standard null reference exception that's occurring here, object reference not set to an instance of an object. So because we've traveled back in time to get this, if I wanted to reproduce the issue at this point, I could set a breakpoint here and then begin to inspect my variables. IntelliTrace by default doesn't collect all of the variable information because of the overhead, but this is enough to get me where I need to be to start investigating. So you might be asking yourself, well, that's great if you have IntelliTrace, but how would I figure this out if I didn't have IntelliTrace? And that's a great question. So what I'm going to show you is the new exception settings window. This window is one we introduced in Visual Studio 2015. Previously, there was an exception dialog that took about 6 seconds to open, and people there was just a lot of complaints about that dialog. So we revamped it and we made it quick opening and faster with a respectable search. So in this list, I am going to select my common language runtime exceptions, and these are my .NET exceptions. And when I check this box next to them, I'm basically telling the debugger, I want you to break whenever an exception is thrown. It's like setting an exception breakpoint. Now, if that's too verbose and I don't want to turn on all the exceptions, I could simply search here for null reference exception and just turn that one on itself. So now when I continue debugging and reproduce my issue again by hitting the select button, I see that the exception occurred on this line of code, just like IntelliTrace showed us, without the need to go in and comment out my try catches to try to get the debugger to break in this location. Okay, so now that I'm at the right point in code and I can inspect my variables, I see here that driver has value, but name is null. So this is the thing that's null for me. And just to step over it, I see that my exception is being caught here, and it's assigning the dummy driver. Well, as I look at this statement here, I'm clued in, this name variable bothers me a little bit because we typically are using IDs in this application. And so trying to compare something by name is a little bit off. So I'm going to guess that if I use ID instead of name, I'll be better off. And I can test that theory out while I'm debugging by going to the immediate window. And the immediate window is just like a scratch pad for coding on the fly. So I can change values of variables here, or in this case, I can change name to ID. I can compare by my driver ID, and then I no longer need this comparison. And now, when I hit enter in Visual Studio 2015, this lambda expression gets evaluated in the immediate window. And previously, that wasn't available to us. Isn't that great, Nikhil?
That's awesome. When did this become available?
Visual Studio 2015, you can evaluate lambda expressions.
Okay.
Okay. So I see that my lambda, if I change it to ID, that fixes my issue. And I'm going to go fix that in the code now. I'm not going to stop debugging. It kind of takes a while for our web client to spin up, so the less times I have to do that, the better. I'm going to want this code to run again. So in order to do that without stopping debugging, I can use a feature called set next statement. And when I right-click on any line of code, I can go to the context menu and look at this set next statement, which its shortcut key is Control-Shift-F10. When I select set next statement, it moves the instruction pointer to the line of code that I selected, and it hasn't executed any code. It's just told the debugger what we want it to execute next. So I'm now going to take out the name and replace it with ID, just like we had done before. So I don't want name, I want ID in this instance, and I want my driver ID. And notice that like I said, I'm editing this on the fly while the debugger is running. And this is a feature of the debugger called edit and continue. So I made this edit. I don't have any red squiggle lines. If I step over it, the code executes. And as I continue, I get the actual picture instead of the dummy picture.
So I don't have to restart my application to fix a line of code?
Correct. Exactly. That's exactly what happens. Well, I guess I'm still getting a dummy picture here for myself. I'm just kidding. So, hey Nikhil, as I'm clicking on these things, I feel like it's taking a little bit to load.
Yeah, it looks pretty slow. But
yeah, it looks pretty slow. I would expect it to be much faster because I'm just selecting myself over and over again.
yeah, just loading up your picture, which...
Can you take a look at this for me and see if you can figure out what's going on?
Sure, it seems like we can improve that. So yeah, what Casey said is, when I'm using this website, it's really slow to load up a new image. And in Visual Studio 2015, we've implemented some performance tooling features directly into your debugger so that you can work with your debugger and fix performance issues on the fly. The features I'm going to talk about today exist primarily in the diagnostic tools window that Casey mentioned earlier. That was the home of IntelliTrace. The things that I'm going to talk about are actually available in all SKUs. If you're using Community, Pro, or Enterprise, you should still have all of these available to you. So what we noticed was loading up a picture for a specific driver is taking a long amount of time. So I'm going to take a deeper look and see what all is going on there. First, I'm going to take a look at the diagnostic tools window, and I can see a couple of different things happening in the diagnostic tools window. Sorry, I'm going to adjust my mic here for a second. I want to point out the memory graph and the CPU graph. The diagnostic tools window shows us the process memory and the process CPU as your application is running. Now, you might have seen something similar to this in the Windows Task Manager. The difference in this view is that our process memory and our process CPU utilization is specific to this application alone. So we can see that the web application we're running is taking up about 600-ish megabytes of memory, and it's consuming no CPU right now because it's not actually doing anything. It's a web page that's standing still right now. So going back to the issue of a long time to load up an image on the web page, I know that when I hit the select, it's going to call the driver route inside my home controller. And what I'm going to do is first I'm just going to find my driver, and after I find my driver, I'm just going to set a breakpoint in my code and start execution from there. So I found my driver method here, and I'm just going to set a breakpoint. And when I hit select, it's going to call the driver method, and this is the function it'll use to actually pull out a driver from the backend service. So one thing that I want to point out is when I hit F10 to step over a line of code, we do a little intelligent thing and calculate how much time that line of code took to run. So if we see, the debug.writeLine took about 1 millisecond to run, and I stepped over again, and whoa, it looks like the getIndividualDriverCached method took about 1859 milliseconds to run. And that might be the cause of this slowness.
That seems like a long time.
Yeah, 2 seconds is pretty long to just load up an image. So that might be something worth investigating a little further. But just to see what the rest of the driver method is doing, I'm just going to F10 over these lines. And I see that they're roughly taking like 1 millisecond each, so they're not that big of a time. These numbers, the perf tips, as we call them, they exist in your editor as you step over your lines of code, and they tell you information about the last line. They can also be seen in the IntelliTrace events view. So if you look down through the events, you can see these step events, and we can see that this specific step on line 104 took about 1 millisecond to run.
Wait, so are you saying that that's a history of all the perf tips as I'm stepping through my code?
This is a history. We keep track of it for you, so you
that's
don't have
awesome.
to write it down.
Normally I have to write it down, exactly.
We also put them up here into blocks. So in the events timeline up here, we make a block for each step and give you a visual indicator of how much time that took. And then you can correlate it with what memory and CPU activity was happening at that time. So another cool trick we can do with perf tips is I'm going to set a couple of breakpoints in my editor, and it's just going to be around this driver's function. So using the feature that Casey demonstrated earlier about setting my next statement to start execution again, there's actually a neat little trick that you can do to make that process a little quicker instead of looking through the right-click menu. You can go to the yellow instruction pointer here, click it, and drag it upwards so that you can drag the next statement and then set it to something earlier or later or somewhere else in the file. I set it to the beginning of the function, and I'm going to hit F5 to run from the beginning of the function to the end of the function. And now the perf tip value will give me the timing for that entire segment of code.
So just running between breakpoints, you can see how long that function took to execute?
Yeah, I can see that segment of code and exactly the perf tip
That's great.
time.
That's going to save me so much time.
We hope so. So yeah, we can see that the timings of individual lines of code and segments of codes like this. Now, another feature that we've built into the debugger is a CPU profiler. So if you want to do a little more advanced analysis and see timings of specific functions in a larger range of time, the CPU profiler or the CPU usage tool will allow you to do this. The CPU usage tool exists in the diagnostic tools window under the CPU usage tab. Now, the CPU usage tool is something that you need to turn on for it to start recording out this information. So I'm going to do just that by enabling CPU profiling. I'm going to remove these breakpoints and continue running. So once again, I've enabled the CPU usage tool, but it hasn't actually captured any information yet. I need to record and redo the process that was slow in my application to record that information so I can take a little more deep analysis about it. So I'm back at my web application. I'm going to hit select. And if you notice, it actually causes a little CPU activity that you can see in the diagnostic tools window. So I'm going to see if that's the case on every picture. And yeah, it's a little CPU activity that happens as the application is running. Now, in order to view what functions are responsible for the CPU activity, I actually have to pause my execution. And I can do that by either hitting a breakpoint or coming up here and hitting the pause or break all button. So I'm going to go ahead and do that. And the CPU usage tab will aggregate out some information about the functions that are running and tell me a little bit of information about that. So this is a tree view where essentially a function, its children will be function calls that it made out. And if we look through, we can see our driver method made a call to the get individual drivers cache method, and this was responsible for 80% of the CPU activity during that selected range of time in the diagnostic tools window. And that sort of coincides with information that we got from the perf tips that this was actually the cause. So if we dig a little deeper into that, we can see that further function calls were made into the deserialized drivers JSON method, and that 80% of time was spent roughly doing all kinds of deserialization work in the application. So eventually, it leaves my home controller and goes out into some third-party code for deserializing a JSON object. So maybe we should take a deeper look at that. What I can do?
Good.
Yeah, so what I can do is I can go to that point in my code by just right-clicking a specific function and hitting View Source. And that will take me directly to the code that was doing that CPU activity and taking up that amount of time. So I got into this get drivers list method, and what I'm going to do here is I'm going to just set a breakpoint and step into it and see what's taking a lot of time there. So I'm going to continue running my application and select out a new driver and F10 over. And as I'm F10ing, I'll explain a little about what this code is supposed to do. It's supposed to take the request that it made to the server to get the driver IDs and the driver names and pictures and things like that and store them all in a cache. However, one thing that is causing it to take a long time is, if I keep stepping, is at the very end, it's taking this information that it's stored and deserializing it out into the actual driver name, driver ID, and the driver picture. So this deserialization step is taking, let's see, about 2 seconds to do. And that's not necessarily something that we have to do every single time a driver is selected, or a car is selected to get a driver. It's something that maybe I can just deserialize it once, and then every subsequent time the application runs, we just store that in a cache. So that information should be loaded instantly. So I'm going to stop debugging and implement that fix. To do that fix, I'm going to simply deserialize once and return the cached version of the deserialized JSON. So I'm going to comment out the returns at the bottom. And my breakpoint is still up here. So I'm going to set another breakpoint at the end, and I'm going to run. So what I'm going to do now is I'm going to time the first time it takes to cache that deserialized object and see how long that takes. And the application will get up and running in about a second. So yeah, the very first time I run the application, it still has to do this work. And we can see it takes about 3.5 seconds. However, every subsequent time, if I hit select, we can see that we've cut down that full 3.5 seconds, so about 9 milliseconds to do this function now. So each subsequent selection of a driver is going to go very fast and smooth. And I can demonstrate that by removing these breakpoints and running the application. And we can see that now whenever I click on an image, it loads up almost instantly.
Hey, I like loading fast.
Yeah, Casey loads fast now, so she has that going for her.
Great.
OK.
Can I ask you a question before you move on?
Yeah,
So
sure.
in the CPU usage tab, I saw something called total time. And I think if you scroll to the right, it says self-time.
Yes.
That always gets confusing for me. Can you briefly explain for me what the difference is between total time and self-time?
Absolutely. Let me pause profiling and show you a little about what's going on there.
Sure.
So I'm going to actually go ahead and select out that CPU activity for what I know to be the first deserialization. And what Casey was pointing out was that we give you a little, we give you a ton of information in this CPU call tree. So first we have the function, and the time I was primarily talking about here was the total time. And this is essentially the total time a function took to run from beginning to end. It includes everything.
Makes sense.
Yeah.
Total time.
Total time. That's just as simple as that. The self-time is a little bit more complicated of a metric. The self-time is all the time the function took to run when it was sitting inside that function's body. So it's discounting all of the time that function calls that function made out to took to run. So if you look at the driver method, it's going to subtract out all of the total time of the get individual drivers cached and only count the function body of the driver to calculate the self-time.
That makes sense.
Sounds good. So another thing to point out is throughout this whole process, I had CPU profiling enabled. And turning on CPU profiling is a little costly for an operation. It slows down our program by about 5 to 10%. So it's not necessarily something that I want to have on all the time. So now that I've found that that was an issue in deserializing my drivers,
Yeah.
I can turn off my CPU profiling to make sure my application is running quick and fast again. OK. So CPU is not the only thing that we can give you more diagnostics information about.
What else is there?
Great question, Casey.
Thanks.
So I'm going to continue running my application. And one thing you might have noticed or might not have noticed is whenever I'm selecting out a new driver, it's causing a little bitty bump in memory consumption of this application. So right now we can see that the application is taking about 380-ish megabytes, but if I hit select, that consumption bumped up a little bit, and now it's taking almost 400 megabytes. And this might be a problem because if I keep selecting out a new vehicle, the memory consumption is just going to keep going upward, and this might be a cause for a potential memory leak that we could investigate a little bit more into.
That seems problematic, but it's awesome that you can notice that by leaving the diagnostic tools window open. Just seeing
Absolutely.
that graph tick up, way cool.
Yeah, so it's something that I might not be even be paying attention to, but in the corner of my eye, I can see that the memory graph is ticking a little upward, and that might be something I should investigate into. So much like the CPU usage tab gives you a little more information about the CPU, the memory usage tab gives you a little bit more information about the memory consumption of your application. So what I can do here is I can take a snapshot and see what all objects are sitting on the heap and what is their consumption in terms of how much space they're taking up. So to do that, I can come into the memory usage tab and I can hit take snapshot. Taking a snapshot will actually go through the heap and tell me what all is sitting on there. So we can see there's about 376,000 objects sitting on the heap. That compromises a heap size of about 135 MB. And that tells me a little in isolation, but I can click it to see what those objects actually are and how much space they're taking up. So this view here is a view of the heap, and on the left, in this first column, it tells you what objects are sitting on the heap, and on the right, it tells you the count and the sizes of those objects. So we can see that the majority of the heap is being taken up by driver objects. And if we can see, there's 150,000 drivers, so it makes sense that they're taking up a large amount of the heap.
Yeah.
So when I click a specific driver, I can actually see what data structures are holding these driver objects. And I can see that about 150,000 of them are sitting inside inside a list here. And what I can do is I can right-click that list and say Find All References, and actually take a look at what places in my code are making changes to that list to either add or remove objects to cause changes in this memory. So I can see this list is actually created from the change we just did to cache the deserialized list. And that's about 150,000 drivers sitting right there. So this heap view is very good in isolation, but maybe I want to investigate further and see what objects are being created to sit on the heap between two different points in time. So to do that, first I'm going to just restart the debugger and get that up and running again. So what I can do here is after my application is loaded, I can take a snapshot to serve as a baseline of a measurement in terms of what objects are sitting on the heap and what their sizes are. I can do a couple of selections along here to increase my memory consumption and take another snapshot. Now, what the memory usage tool does is it actually diffs those two snapshots together so I can see what objects have been created to sit on top of the heap now. So I can see that the heap size grew by about 10 megabytes, and that was just from making one new selection on a vehicle. So I can go through and select that diff to see what new objects have been created to sit on top of the heap now. So I can sort it by the size difference between the two snapshots, and I can see that most of the increase in size was sitting inside of driver objects that were created between those two snapshots. Now, the bottom view, it tells me where those objects were created. And I can see that all of this was in one driver that was created that was sitting in a dictionary somewhere. And this dictionary, it looks like a driver cache, and I can actually go to its definition and see that this driver cache has created a new driver, and that's sitting inside that driver cache, and that's taking 10 additional megabytes every time I click select to open up a new driver. That sounds bad.
Yeah, it seems like a problem.
Casey, do you think you can take a look at why this is causing an increase in memory?
Yeah, sure, I'd love to take a look.
Sure.
Thanks for using the diagnostic tools window to get me here. Okay, so now I'm at the driver cache, and I'm just going to F12 to go to that definition where this is happening. And it looks like I've got two methods in here: add driver to cache, get driver from cache. Pretty straightforward. And I've got a key and a driver, and I'm caching the key with the driver. All this looks pretty normal. So in order to investigate this a little further, I'm going to go ahead and set a trace point to figure out what these keys are. I can set a trace point by clicking a regular breakpoint, or F9, but you'll notice that this breakpoint has a toolbar that we introduced in Visual Studio 2015. From this breakpoints toolbar, you can disable and enable breakpoints, as well as open the breakpoint settings. So breakpoint settings open in this convenient peek window. It doesn't cover up any of your code, and it's a non-modal dialog, so you can copy-paste between the breakpoint settings and your code. You'll notice there are two things here. We've got conditions and actions. There are three conditions that you can apply on a breakpoint. We've got conditional expression, hit count, and filter breakpoints. Conditional expressions are really great whenever you don't need to break every single time, but there's a specific, well, for lack of a better word, condition that needs to be met before you can break. You can put anything into a conditional expression breakpoint that evaluates to a Boolean variable. So in this instance, I get IntelliSense, and I can find, so for example, I could do key, and I could compare that to something if I wanted to, and I can make this expression as complex as I want. So anything that evaluates to a Boolean variable.
So that'll only break if that condition is met?
Exactly. You're picking up on this.
Sounds very simple.
It's the same thing for hit count. So with a hit count breakpoint, all you have to do is put a number in here. And so instead of a Boolean expression condition, we will record for you every time this breakpoint is hit. And so if I am going through a loop, hit count breakpoints are great for loops. If I'm going through a loop, and let's say I experience an issue on like the 105th iteration of the loop, I'm not going to sit there and F5 to that breakpoint 105 times.
Absolutely.
Hit count breakpoints make it great, because then I can just go, okay, on 105, break me. And then I can start stepping through the debugger that way.
Sounds very useful.
Yeah. The last type of breakpoint I'll mention for conditions is a filter breakpoint. And this is great when you're doing multi-threaded debugging. You can see here that you can filter by machine name, process, or thread. So if you find your thread ID and you're doing multi-threaded debugging, you can set thread ID to equal something, and then you will only break on that breakpoint when the thread is the proper thread, or when any of these conditions are met that you set up for your filter breakpoint. The second thing you'll notice is that we have actions. Currently, we only have one action, and that is to log a message to the output window. So I had mentioned very briefly, debug.writeLine, and how that was showing up as program output. Well, when you use debug.writeLine, that's actually making edits to your code, right? So if I wanted to change the message or the string, I'd have to go in and edit my code. But when I'm using a trace point, I can log a message to the output window. There are three types of text that you can log. You can log plain text. So in this case, I want to log that I'm adding my driver, and then I can use curly braces to get values of variables. So when I put a curly brace here and start typing, you can see that I get IntelliSense, meaning that anything you put within curly braces will go and evaluate that variable and return the value to you when the message outputs. And the last thing that I can put in here is a pseudo variable. We've got some rich pseudo variables in here, like call stack, function, thread ID, and I'm going to use function in this case. And so what this is going to do, it's going to print the name of the function of which the trace point is inside. And I want you to notice down here we've got a continue execution checkbox checked. So this is what makes it a trace point instead of a breakpoint. I could easily hit this breakpoint and log a message, and you can combine your conditions and actions. But in this case, I'm just going to have it I'm going to have it continue past, but log a message. And I'm going to do the same thing down here for get driver from cache. And a shortcut, if you can click on the settings, or you can right click and go straight to actions. And I'm going to do the same thing. I'm going to do getting driver, and I'm going to have my key in curly braces, and I'm going to do my function also. So I can just hit twice, that closes out of my way, and I'm going to reproduce my issue that you found for me with the memory. So select multiple things, get another person in there, back to me again. I like me. Me a couple more times, just all of the me. Anyway, so I can see trace points are appearing in my diagnostic tools window, and those are the very trace points I have set over here in code. And you can even see those appear in the you can see those appear up here in the timeline track. Can you see those appear up here in the timeline track?
Yeah.
Do I just have to zoom in?
Yeah, the debugging's been running for a few minutes now, so.
Okay, so the timeline gets a little long. They're there. So I want to, thanks, Nikhil. I'm going to reset my view and now look at all of I know the trace points are here. So I just want to see the trace points only. So I'm going to use this search feature of the events tab to just search for my trace points. So now I can see the history of all the trace points that I've been logging. And the last thing I clicked on was me several times. So it doesn't really make sense to me why I see adding driver, getting driver, adding driver, getting driver. For me, if it's a cache, right, I just expect it to have adding driver once and getting driver multiple times after that. So when I printed out the key here, you can see that it has a string associated with it, and that is the key. So my key is just a big string here. And I can see it has a sequence in it. I'm having a little trouble viewing this here in IntelliTrace because I have my font cranked up real big. So I'm just going to come back here and turn this trace point into a breakpoint, hit it, and inspect my key manually. So my key here, this is the same string that I was seeing logged to the output window.
That looks kind of hard to read, Katie.
It definitely could be.
It's just a JSON string, and it's, yeah.
Yeah, exactly. So that's a great point, Nikhil. You reminded me that we have in the debugger, we have this magnifying glass that appears next to text variables. And when you click on the magnifying glass, we have different visualizers that are available to you. The text visualizer will just display plain text, XML, HTML, and the JSON visualizer. And I love using the JSON visualizer for structured data like this because it gives me a really quick view of my string. So I can see my ID is 2, my name, and I have a sequence number here, which I am not sure I was expecting. Nikhil, did you add a sequence number for logging purposes?
I might have done that.
Yeah.
My bad.
So that would make sense. So every time I change or click on myself, the sequence number goes up, and we're caching by the key. So the string keeps changing. So I'll put this back onto a trace point here. And so instead, like I fixed my bug earlier, I'm just going to use the key as the ID of my driver instead of that whole string that my driver appears. So uncommenting out that code just makes my driver. And now I'm going to hit continue, and I have my trace point still here. So now when I select myself several times, I would expect 1 adding and several gettings. And I can see that right down here. Several getting drivers and then 1 adding driver. Perfect. So now that I fixed that
So the memory isn't
issue,
changing at all now either, so.
Oh yeah. I can just glance right up here and you can see that it's a flat line instead of that constant growing that we were seeing before. Yeah.
So.
Thanks for your help, Nikhil. I like it. So I was actually working on this app earlier by myself, and as I was clicking around, I was noticing that we've had a lot of turnover on our PM team, and I don't think we've updated our list of PMs in a long time. So I wanted to kind of make a PM buffet where we could see what PMs were available, or what PM drivers we had. So I clicked on this link to take us to our PM team, and I ended up in the debugger. And I was working on this, and so I hard-coded a debugger.break in here. So what a debugger.break is it's a hard-coded breakpoint. I don't have to set it in the gutter. I don't have to F9 to get it. And under the covers, it's an exception that's being thrown. So I've also wrapped it here in a debugger.isAttached block. So when I have it inside debugger.isAttached, if I'm running this and a debugger is not attached, and it doesn't affect it at all. But if I didn't have a debugger attached, and I didn't have this conditional if block here, my exception would crash because it would basically be an unhandled exception.
Okay.
But debugger.isAttached is not just for using a debugger.break. You can add this block anywhere, and for example, you can add additional logging when a debugger is attached. You can change or assign specific variables if you're trying to test something out. So that's really convenient and handy, and in my case, I've just been trying to get working this one method. So having a consistent breakpoint right here has really been helpful for me. So I'm going to continue past that and show you the problem I've been having that I didn't fix before we got here. So I'm expecting to get, again, a list of drivers with pictures and names associated with them, but I'm not even getting my dummy variables. Or not even getting dummy values. So I feel like something is going on here. So I'm going to refresh this page, hit my breakpoint again, and just start stepping through the code to see what the problem could be. And as I step over, I see I have a driver list. I step over, I have all my drivers. Well, all my drivers doesn't have anything in it right now. So I don't know, that should have some drivers in it, I would expect. So if I come down here to my autos window, you can see that I have return values in here that the debugger's populated. So I've got 3 different methods in here that are getting called, and I can see what each of those methods returned. So getDriverList returned a list with 150,000 drivers in them. When I trim that list down to like the real drivers that we care about, I get 19, and then when I sort the list, I'm getting nothing. So I wouldn't
That sounds wrong.
Yeah, exactly. I wouldn't expect a trim to a sort to change the size of the list.
Yeah.
So I'm going to go and investigate that sort method. I'm going to use your trick and just drag the instruction pointer back here, so to before this is executed. And I could, you know, F11 to step in, or but I would step into get drivers list, then trim drivers, then sort drivers. But I'm going to choose to use a handy feature of the debugger called step into specific. When I right-click on a line of code with multiple function calls, I can go to the context menu, see step into specific, and get the list of available functions for me to step into. So I'm going to click sort driver list, and it's going to execute get drivers and trim and land me right in sort.
Wait, so I don't have to find that function wherever it is in my code and set a breakpoint there and then run to that to get here?
You nailed it, Nikhil. There's no F12 when you need step into specific.
Okay,
you
so
can just go right there.
That seems very useful.
Yeah. And as I look through, just scanning this with my eyes, this method isn't doing anything super interesting, but it is calling ordered list, and I can see that right here. I could set a breakpoint again, but I've been doing a lot of breakpoints. It's easier sometimes for me if I right-click on this line of code, and we have this feature in the debugger called run to cursor. And what this is going to do is it's going to basically set a temporary breakpoint, and it's going to run execution up until this line that I clicked on. So when I click that now, it executed all this code and it landed me in ordered list because it got called from there. And this eliminates the need to set temporary breakpoints and remember to delete them and hit them every time.
Wow.
Yeah. So that's how I run to my cursor. And I'm just going to keep stepping into this just to do some investigation. Oh, I stepped into my Lambda expression here. I can see that I have a driver, so drivers are in this list, obviously. And sometimes when I'm going through lists or Lambda expressions, it's helpful to know what this driver is and to keep it around. So I'm going to do something called pinning this data tip, and you can see this pin to the right of my line here. And when I pin the data tip, it appears next to my code in line here. It scrolls with my code, and it's just an easy way to glance back and forth as I'm stepping through. So I'm going to keep stepping through, and I'll show you that the data tip keeps updating as I step through. Now, let's say sometimes when I'm stepping through methods, this object is important to me, and I want to hold on to it to remember it and to maybe compare its values to something else that I'm iterating through in my list. But this D variable is going to keep changing. What I can do to hang on to that variable is something called make object ID. So if I right-click on the variable I want to add, and I can select make object ID, And when I do that, I get a $sign and a number in the locals window. And I can use that as like a handle on my object. So I can put $1 here, and it'll show me this driver 4. So as I continue to step through my Lambda expression, my driver changed, but my object ID didn't. So I still have access to all of these details that I can compare to whatever I need to if this is my interesting object. Now, there is some overhead for maintaining object IDs, so I recommend that when you're done with it, go ahead and delete your object ID. So now I don't have that hanging around in memory anymore, or I don't have it in the debugger. So as I was showing you that and stepping through here, I realized that I made just a very silly mistake. And what happened was I forgot to assign this list that I'm creating to the list I created in the beginning. So of course it was an empty list. So all I have to do to fix this issue is actually assign the ordered driver list that I created to the list that I'm sorting. And you can right-click and clear the data tip that way. Okay, so now let's see if this worked. I'm going to drag my instruction pointer back up. I'm going to step over this, and I can see now I have objects. It's not 0.
You found the objects.
Yeah,
So.
they're there. The last thing I really wanted to show you today was that now if you look at my call stack, I'm 3 layers deep. So I stepped into specific, and this happens a lot when you're debugging, right? You just step into and end up 6 or 7 layers down past where you kind of want to be or go back to. So you have to step out 6 or 7 times. Well, that run to cursor feature I just mentioned can be used in the call stack. So get all drivers is the interesting method for me. Instead of step out, I can right click on it and go run to cursor, and it's going to zip me back up the call stack and right to the line of code after it got executed. So you can see that my call stack changed, I executed, and I stepped out of those methods. And as I stepped out of those methods, I want to hit continue now and just verify that that fix we made with the empty list is now a full list with people. And this might take a second because like I said, don't know what I'm caching. Okay, so I do. Now I get pictures, and I see I don't quite know who all of these people are, so it's probably time we go back and update our data set for this. Cool. So that is what we have for you for Visual Studio 2015. Now, do we have a little bit of time? What time is it? We got 10 minutes.
We have 10 minutes. We can do it.
I say we do it. Okay, so I'm going to pop over to Visual Studio 15 and show you one of the new features that we were working on. So this is Visual Studio 15, which is vNext. And I wanted to take you back to the beginning. So do you remember when I landed on that aggregate exception, Nikhil, and you were like, you forgot to start your service?
You had to go through that ugly, ugly dialogue to get your exception out.
I did. And I didn't even realize that it had inner exceptions on it, but now in the new exception helper, I can immediately see that those inner exceptions are in my face. And so those inner exceptions are in my face for me to look at. So I've got 3 of them actually, and I can just quickly navigate between them. And had I had this, I could see unable to connect to the remote server, and I wouldn't have even needed you to diagnose that issue. So the point of this exception, the new exception helper, is that it works in both, in all of the languages. So in C++ and .NET, you'll get this convenient exception helper that's compact and hopefully easy to use. And if it's covering up any of your code, simply drag it away, and you can put it back. So we encourage you to download VS15 Preview and try that out. Nikhil, did you have something you wanted to show us too real quick?
Yeah, definitely.
Okay.
So let's switch on over. So coming in Visual Studio 15, we have a couple of improvements to the CPU tool that I showed a bit earlier. Let me just go to that and log in. So the CPU usage tool, while debugging, we've implemented a couple different views. we've added something called a flat list of functions, where instead of a hierarchical view of functions in a tree, as we showed in the call tree earlier, we simply can give you a list of functions and what was the timing of those functions. So if you can see here, this is a similar view to what we had earlier in the call tree, but this data is now aggregated by function, and we just have a simple list that gives you a quicker insight into what's going on in your application. In the call tree, we're also doing a couple of smarter things in terms of analyzing what's going on in your application versus what's going on outside of your applications. In terms of if you made a call out to external code and there was a third-party library or .NET framework that's doing some heavy lifting for your application, we can know that and make some more intelligent visualization of that data. And you can see that in this grouping of the Newtonsoft JSON deserialization into an external call, where we can mine out some statistics about that external call and tell you a little more information about that. These are just a few of the of some new features that we have planned for the CPU tool, and we hope to keep building it up and make it awesome. So
awesome. I'll take that back from you, Nikhil.
Sounds good.
Thanks for showing us that. I'm really looking forward to VS15.
Me too.
So just real quick, in the last 5 minutes that we have, we showed you our cool demo today. Hopefully you saw some tips and tricks that you hadn't seen before or want to use now. Just a quick recap, we did some stuff with the startup project, showed you IntelliTrace, showed you exception settings, and lambdas in the immediate window, which is my personal favorite. I get really excited about that one. We heard from developers that was a pain for far too long, and edit and continue. And Nikhil, what did you show us today?
So we went over the event list. One thing to point out in the IntelliTrace features, the events that showed up in the IntelliTrace, some of them belong only to the enterprise SKU, but a lot of the events there, including the debugger events and the trace point events that you mentioned, show up in community and pro as well.
Great. We saw perf tips, yeah.
The perf tips, as you step over lines of code, you can see the timings of that. We went through the CPU usage tool, where we can capture information about how long your functions are taking to run and take a deeper look at that, as well as the memory usage tool, where we can do the same with memory and see what objects are taking up space on your heap.
Great. And then at the end there, I came in with trace points and breakpoint settings and showed you how to use debugger.isAttached. Some cool things like step into specific and run to cursor. And also how to use run to cursor from the call stack, which is a very little known feature, but super helpful. We want to ask you out there in the webosphere to click this link and sign up. When you click this link, you'll go to a forum. And what we're trying to do is be in better contact with debugger users or people who care about debugging. And because we obsess over our customers, right, Nikhil?
Absolutely.
Absolutely. And so through this, through filling out this form, your contact information basically comes to me with your email. And so I have, sorry, Mike. I have the opportunity to reach out to you, possibly send you a survey or a newsletter, or keep you up to date with what's happening from the debugger, and potentially be able to ask you questions.
And from my end, if you're interested in seeing any kinds of newer stuff that we're working on before any of the public sees it, we have the opportunity to reach out to you and show you some new stuff that we're working on and get you involved and get your feedback and help us drive the product.
Exactly. That's a great way to put it. Oh, and I'm pretty sure you have one of these just for people who are super interested in profiling.
This one will work for both of us.
Great. So. Perfect. So then lastly, I put up here some resources for you to look at. We've got our team blog, and on the final slides, I'm going to put a link to the sample code that we used today. For VS-Diag, we have a Microsoft GitHub repo for VS-Diag samples. And that's all we have for you. Thank you so much for joining us today.
Much.
Bye-bye.
Bye.